Alright, we've looked at a couple forms of straight lines, right? We had our slope-intercept form, y equals mx plus b. We had our point-slope form, where we had x minus x1 plus y1 like that, y equals that. So now we want to go to a general form of a straight line. And usually that's written as ax plus by equals c. Now we're going to move away from an actual equation pretty quickly to an inequality. But just to show that this is indeed still a straight line, notice that I can subtract ax from both sides, so I get by equals c minus ax. And then divide both sides by b, and I get y equals c minus ax over b. And, well, if I want to rewrite things a bit, I can do minus a over b times x, and then plus c over b. And there is my slope. And even though I'm using a b, right, I could rename that as b, and so that's just y equals mx plus b. So this general form is also a straight line just like these others, and it just comes in handy for the types of things we're going to do now, which are we're going to look at linear inequalities in two variables. So we have our linear inequalities in two variables. Okay, so we just want to look at things like 3x plus 2y is less than or equal to 5. And, whoops, again, I'm never quite sure how I do that, but we want to look at this, and before, we could look at points that satisfied this, an equality and so forth. So if we think about the equality, right, if I let x equal 1 and y equal 1, that's 3 times 1 plus 2 times 1 equals 5, and certainly that's less than or equal to 5. So x equals 1, y equals 1 is a perfectly good point to put in there. But on the other hand, notice that x equals 1 and y equals 0 is also a perfectly good point, because if I take 3 times 1 plus 2 times 0, in that case I get 3, which is indeed less than or equal to 5. So that also satisfies that inequality. And so what we want to do is look at sort of this difference of inequalities compared to equalities, and we're going to in particular look at it from the standpoint of turning this algebra here into a picture, a graph. And so basically the way we do that is if I want to graph 3x plus 2y is less than or equal to 5, what I do is I start with 3x plus 2y equals 5. And actually, in this form, the easiest way to come up with a graph is to come up with the two intercepts. And so notice if I let x equals 0, then I have just 2y equals 5, because since x equals 0, that disappeared. And I can solve that equation. I can divide both sides by 2, and I get that y equals 5 halves, or 2.5. And similarly, if I let y equal 0, then I'll get 3x equals 5. Divide both sides by 3, and I have x equals 5/3, or that is 2.67 about. Okay, now I can use those 2 points, since I know I have a straight line. I can go here to my xy Cartesian plane, and I have x equals 0, y equal 2.5, so here's x equals 0, I go up here to 2.5, and I misspoke here, not 2.67, it's 1.67. But there's a point there from the 0 and 2.5, and now I go here to this point, which is x equal 1.67. So there's 1.67 and 0, and there are 2 points on my straight line. So now I can draw that straight line. So there's the straight line part. Now I need to add the inequality. And what we have is this nice property that this inequality splits the plane into 2 pieces, either those pieces that work and those pieces that don't. And so all I really have to do is check any point on either side of the line. Now in this case, the easiest is 0, 0. So I check 0, 0. And I see that 3 times 0 plus 2 times 0 is equal to 0, which is indeed less than or equal to 5, which is what I need. And so that's good. So that means everything on this side of that line fits my inequality. And so there I have just drawn a picture of what that inequality means in terms of points. So any of these points I pick should work. And so notice, as long as if I pick anything where both numbers are negative, it works. Anything where x is negative is going to work as long as y is not too big. Now out here though, so notice this is 1.67, 2.5. If I come out here and pick something like that, looks like about the 0.23, notice that if I try that point, so I have 3 times 2 plus 2 times 3, that's equal to 6 plus 6. Oh, did I get that right? Was it? Yeah, 3 and 2, yep, okay. 6 plus 6, and so I get 12, but that is not, okay, so I'll put a big X over that. That is not less than or equal to 5, right? 12 is greater than 5. It didn't work. So this point didn't work, but if you try anything over on this side, it is going to work. And that's really all that's all there is to it in graphing these inequalities. We'll look at a couple more examples in another video. But so that's an introduction to these inequalities, so we'll stop there.